This video shows you how to improve print quality when some of the common issues appear. Before describing the most typical image quality issues, make sure you follow this general advice. Make sure that you are using the correct substrate preset for your substrate with the correct ICC profile. You can download HP published substrate presets directly from the front panel of the printer if it is a web-connected printer. If your printer is not connected to the internet, you can download the substrate profile from the web page www.hp.com/go/media solution locator and import it from the embedded web server to the printer. If the substrate profile for your substrate is not published and has not been provided to you by the reseller or the substrate vendor, then try using the generic substrate preset for the corresponding substrate family. If the generic substrate preset does not work properly, generate a new substrate preset following the guided front panel process. For the purpose of this demonstration, the substrate preset MySav is generated. Make sure the right substrate preset is selected in your software RIP and the right ICC profile is installed and used for the color management process. More details about how to install and use substrate presets can be found in the user's guide and in some specific HP Latex 300 printer series videos. The environmental conditions for best printing quality are relative humidity between 40 and 60%, temperature between 20 and 25 degrees Celsius, 68 to 77 degrees Fahrenheit. The published substrate presets have been tested under these conditions. If your environmental conditions are outside of these limits, substrate presets may require some adjustments to print properly. If your printer model is a Latex 365, then check the Optical Media Advanced Sensor, or OMAS, is working properly. If it is not working, clean it and try again. This sensor does not work with some porous or translucent substrates, or that have a reflective backside. For some thin substrates, the OMAS works when the substrate is loaded, but stops working while the machine is printing. In these cases, we advise you to manually deactivate the OMAS. If your printer model is a Latex 335 or 315, or the optical advanced sensor of your Latex 365 is not working on the media you are using, then calibrate the substrate advance by printing the substrate advance check plot. Locate the lightest columns and make a note of the number at the bottom. Insert the number in the substrate preset and print mode in use. Make sure the printheads are aligned and that not too many nozzles are out. A small number of non-working nozzles are unlikely to have any effect on your prints because the printer can compensate for this during multi-pass printing. Clean any printhead that is not performing adequately. If you are not sure which printhead to clean, clean all of the printheads. Sometimes a single cleaning action may not completely clean every nozzle. Print the status plot and consider cleaning again. You can change the curing temperature, the advance factor, the interpass delay and vacuum while the machine is printing, and check the effect of the change immediately. You will need to save the changes as soon as you find the best possible values, otherwise the adjustments will be lost for future jobs. The generic substrate presets cannot be modified. That is why it is not possible to save the values if you are using any of those substrate presets. You can clone the preset and change the settings from the cloned ones. This section shows the most common image quality issues, the possible causes, and the way to fix them. If your plot presents graininess or bleed, check the following. Print the optimizer check plot on the same substrate and with the same preset that presents the problem. If the plus row has less grain or bleed than the equals row, then the level of the optimizer you're using is not enough. Go to your substrate library on the front panel or in your RIP. Select your print mode and increase the amount of optimizer in steps of 12 units in the advanced settings. Print again the Latex optimizer test plot and check that the plus row and the equal row have a similar level of grain and bleed. Increase the level of optimizer again if necessary. Ensure that the vertical correction option is disabled. Ensure that the color variation and test line sharpness correction option is disabled. Align the print heads. Make sure the substrate advances correctly as explained in general advice. Some substrates deteriorate during long periods of storage or during long shipment by sea. To confirm that this is the cause of the grain, try cleaning part of the substrate with alcohol and print on the cleaned area to confirm that the problem has disappeared. If this is the cause, consider trying a new roll. The warranty of some substrate benders covers this problem. If the graininess appears mainly when printing with the ink collector, the cause may be some substrate deformations over the ink collector. Use the take-up reel to better control the substrate and make sure it is perfectly loaded, so the tension of the substrate is the same all along its width. Some degree of banding can be expected with a low number of passes. If you are using a print mode with 6 or fewer passes, the general advice is to use a print mode with a higher number of passes. In any case, try the following remedies if you want to improve horizontal banding issues. If bands affect all colours across the width of the printed image, the cause is probably a substrate advance problem. Make sure the substrate advances correctly as explained in general advice at the beginning of this video. If bands affect only some colours, the cause could be a defective printhead. The optimizer printhead is unlikely to cause this kind of problem. Make sure the printheads are aligned and not too many nozzles are out as explained in general advice. If after 2 iterations of the printhead cleaning procedure you are still experiencing horizontal banding affecting only some colours, replace the printhead with the greatest number of block nozzles. Different types of vertical bands may appear for different reasons. Try the following suggestions to mitigate this problem. If the plot shows regular vertical bands matching the shape of the platen, align the printheads. Ensure that the vertical correction option is enabled. Remember to disable the vertical correction when you no longer need it because it may increase grain. Reduce the vacuum level in steps of 5 mm, H2O. Reducing the vacuum level too much may cause substrate crashes and/or smears. After reducing the vacuum, consider using the substrate edge holders to avoid lateral crashes. When low levels of vacuum are applied, using the take-up reel helps to control the substrate. Part of the curing warm air goes to the print zone, and it takes some time to reach a stable temperature in this area. The temperature in the print zone is lower when the printer starts to print, mainly the first job of the day. Then when the printer has been printing for a while. The ink quantity has also a big effect on vertical banding issues. Try reducing the ink quantity used for this print mode. This may have some effect on the output colours. Another alternative is to print more slowly, either by increasing the interswath delay value or by increasing the number of passes. If applicable, use the software RIP to group jobs together so that printer temperatures remain more stable between jobs. If irregular or isolated vertical bands with abnormal levels of graininess appear, it may be caused by some substrate deformations that are generated under the curing module and reach the print zone. Decrease the curing temperature on the substrate preset in steps of 5 degrees centigrade, 9 degrees Fahrenheit. Wait some time to allow the system to reach the new temperature and stabilize. In that way, the substrate thermal deformation will be reduced. Increase the vacuum level in steps of 5 mm, H2O. In this way, it will be more difficult for the deformation to reach the print zone area. There are various different circumstances in which oily or easy to smudge areas may appear. If the problem can be seen only at the start of the first print after the printer has been idle for some time, then pre-warm the printer before starting to print and adjust the print queue to print first those plots that have a low quantity of ink. When the symptoms can be seen only in certain parts of the print that use a lot of ink. Try reducing the ink quantity used so that the plots are easy to cure. This may have some effect on the output colours. Increase the curing temperature of the substrate preset in steps of 5 degrees centigrade, 9 degrees Fahrenheit. Wait some time to allow the system to reach the new temperature and stabilize. In that way, the printer applies more energy to cure the plots. Increasing the temperature may increase the substrate thermal deformation. Another alternative is to print more slowly and keep the plot under the curing module for a longer time. The print speed can be reduced by increasing the interswath delay value, or by increasing the number of passes. If the oily finishes appear minutes or hours after printing, then store the print face up and uncovered. The effect normally disappears after a while. You can find additional helpful videos at www.hp.com/support videos and on our YouTube channel, youtube.com/HP support advanced.